In this video, I'm going to cover lists. I'll begin by giving a broad overview of what lists are and describe them in relation to the first sequential data type we learned about in Python, the strings. I'll show you how to create a list, access elements from within a list, modify those lists. That's something new for a list we couldn't do with the string. How to use lists in a for loop structure. How to use split and join. Those are two methods that act on lists, or they involve lists, I should say. One is called on string objects. And then finally, we'll do a short exercise that'll have some relevance to your homework. So what is a list? A list is a sequence of values. We saw strings, which are a sequence of alphanumeric characters. Lists can be sequences of single characters, but they don't have to be. I'll refer to the values in a list as elements or items of that list. Specific syntax, we'll see elements are separated by commas, the entire list enclosed within square brackets. And notably, elements in a list can be of any data type. So simplest way to create a list is to enclose the elements in brackets, separate them by commas, and assign them to a variable. So these three examples, we have the variable cities, which is being assigned a list of two elements, both of which are strings. A list called numbers, being assigned a two-element list. Both elements are integers. And then finally, a list can be empty. And here we have a variable called empty being assigned an empty list. Now these three examples, or at least the top two, have elements of the same data type, at least within the list. String, string, in cities, integer, integer, and numbers. But a list can be heterogeneous. A single list can have a string as an element, a floating point number, an integer, and even another list. And if that's the case, we call this 10-20 list a nested list. One way to create a list without having to type each number that you'd want to put in there out is to use the range function. So range is a function that actually generates something called a range object, which is a sequence like a list, but it doesn't have all of the benefits of a list. And so what we'll do is use the conversion function, list, to turn the output of range into a list. So the range function can take 3 parameters, needs only 1. And somewhat remarkably, the required argument here of the stop is the second. And we'll see how that works out. Oftentimes it's the leftmost argument is the one you really need. Optional ones follow. That's not the case with range. So if you call the range function and pass an argument of 10, convert that output to a list, what you'll get is a list of integers that by default starts at 0 and will include elements up to but not including the stop value. So you can call range with 1 argument, and if so, that's the stop. Your output will be a sequence of integers beginning at 0 by default, up to but not including whatever the argument number is. In this case, the argument was 10, so we go up to number 9. If you call range with 2 arguments, here 2 and 5, it's the second of these that's the stop, and the first, the start. So the output of this line would be a 3-member list, 2, 3, 4, beginning on the start and going up to but not including the stop. And then finally, if you call range with 3 arguments, the leftmost, the first is the start, the second is the stop, and the third is the step. So that is starting at 1, going up to but not including 10. What integers are included? Every 2. So essentially that gives you the odd numbers. If you wanted only the even numbers, one way you could get that is by specifying a 0 here instead of a 1. Now, even though 0 is the default start, if you only passed a 10 and a 2, the range would see the 10 as the start and the 2 as the stop. So it's easy to produce a list of even numbers. If so, there you go. Accessing elements in a list. Elements, that is one or more, in this slide only we're looking at only one, can be accessed using their index location. So in this case, we're having a variable called cheeses. It's being assigned a 3-element list with the strings cheddar, edam, and gouda. So if we only wanted to refer or use, access, the leftmost element of this list, cheddar, we would do so by typing the variable name, cheeses, followed by square brackets and an integer referring to the index location. The leftmost location is going to be 0. The next would be 1, 2, all the way up to the length of the list, -1. You can use a negative value for indexing, and what that'll do is measure from the right. So it counts backwards from the end of the list. So in these lines, we have my list equals list converted output of range 10. So here we go, a list 0 through 9, every integer. If you wanted to access the rightmost, the last element of that list, you could do so not by counting how many there are and figuring out what index to use, but simply putting the -1. So from the left, you start at 0. From the right, you start at -1. So it's not symmetrical like that. But what you get from my list -1 index is 9 in this case. So a few slides ago, I showed you a nested list. So here the variable list is being assigned 4-element list, a string, a floating point number, an integer, and a 2-element list as the 4th element. If you wanted to reference this value, I can't quite highlight it, but it's the 10, 20, 2-element list, you could do so by creating a new variable called sublist and accessing the 3rd element. 0, 1, 2, number 3 element. That's why there's a 3 here. Sublist 0, you'll get 10. Now, if you don't want to create this intermediate variable, you can access either 20 or 10 simply by referring to the overarching, the first variable name. And you do that using 2 indexes. So we've got list, and then enclosed in brackets a 3, and then enclosed in brackets a 1. So what that looks at is the first, this 3 is read, and it's referring to this. Then the 1 is read, and it's referring to the 20. If we wanted to get the 10, we would put a 0 here. Now, if you try that, though, really using 2 index locations, for the number 2 element, so 0, 1, 2, for the 5, if you try that, you're going to get an error. Int object, so 5 is the integer, has no attribute get item. It can't make any sense of that. But if your list isn't heterogeneous, then this can be more useful or more widely used within the same object. Now, one of the big benefits of lists, and one of the ways in which they differ from strings, is that they're mutable. And what that means is after you create a list, you can change the value assigned to any element of it, or modify its length and so on, and still use the same variable name. With strings, they are not mutable, so you can't just go in, change a letter. You're going to need to slice that string and create a new string variable if you want to use a string input to get to a string output. So in this case, got my list. It's the list converted range 10. We can access the number 7 element of this. 6 here. Sorry, lost that. Well, what would happen here? We assign a value of 100 to a specific value, a specific element of that list. Sorry. So if we print it, then the list looks a little bit different. I can show you here. There we go. So I did a shorter example so I wouldn't have to type out. But we create a list, assign a value of 200 to the element at that location, print it out again, and there we go. If I try that here, get an error because you cannot simply change one letter of a string. So here we go. We have a places list, 3 strings, locations in the state of Alabama. We can assign a different string to be the 0th element. We can assign another string to be the rightmost element. And then, well, we'll cover this in a second. You can print out these places. We got AUM, Montgomery, ASU. So Mobile was switched to AUM, Troy was switched to ASU, Montgomery was not affected, but we're only making reference to a single variable here, places. If we want to, we can also change multiple list elements at the same time. So in this case, list 1 is a list, 4 elements, individual A, B, C, D letters, strings. If we want to replace some of those with the strings X and Y, we can, but we don't insert them at a single location. We're inserting them in multiple locations. So 1:3 means at the 1 index spot, up to but not including the number 3. So that includes 1 and it includes 2. And so the output would be AXYD. If, for some reason, we wanted to pop in BC, that is 2 individual strings, we could do that. Instead of doing it like this, with 1:3, if we did 1:1, there's only one integer there. But what it does is it will insert our new list in that 1 index spot. So it creates a new 1 index element, bumps D, which used to be the 1 index element, up to the number 2. F was the 2, becomes the 3. And this little BC becomes a nested list. If, though, we didn't have the :1, but rather just the 1, what would happen? Copy this over, we'll see. Okay, insert equals BC. So we'd list 1 equals inserted. What we get is the nested list at the number 1 index location, but we're missing D, so that gets replaced. If you don't want to replace, but just insert at a spot, you use it like this. The location, colon, and then that same location. We'll insert it. How to delete elements from the list. One way to do that is to reference the index locations of the elements you want to remove and assign them merely an empty list. You can also use the del for delete operator. You assign the elements you want deleted within the list. So if A is a 3-element list with the strings 1, 2, 3 spelled out, you can del A 1 index, and then if you print out A, it's gone. The list becomes a 2-element list with just 1 and 3. You can delete more than one element at a time by using this slicing notation with the start and the up to but not including stop with reference to the index list, and that can cut down the elements more. And with the slicing, if you wanted to cut off after a certain point, you just put the start that you do not want to be there, and you don't need to figure out how long your list is or anything. You just put a colon and then nothing on the right of that colon, and it'll say get rid of 3, the 3 index location, and everything to the right of that. Append. Append is a list method in which will add a new element to the end or the right side of a list. So if you have T, the variable T is referring to a 3-item list with the strings A, B, C. You can do T.append. Remember how methods are called? We have the object, a dot, the name of the function. If you're passing a D string, you can then print, and it's A, B, C, D now. Extend can take a list as an argument and appends all of the elements. So if you append it, so if you extend T1, ABC, if you extend T2 onto that, DE, you can get a kind of a clean ABCDE list. If you called append, what would be different? I'll just type it in here. Your end would be a nested list. So it would take all of this and insert it as a single element. Extend works with 2 lists and can put them together as a single list with no nesting. So here's a list with a while loop structure within a function. So we have define the function print colors, no parameters. Color is a 3-item list with strings red, green, blue. Got a looping variable, initialize that at 0. While I is less than 3, print colors I. So that's the I index of colors. Initially, the first time through, it's going to be 0. It's going to refer to red. Then I gets incremented. I is 1, so this condition is still true, so this will execute. Now I is 1, it'll refer to green. I gets incremented to 2, that's true. This is now colors 2, which is blue. I gets incremented to 3. This is no longer true, so it exits the loop, and you won't get this executed anymore, which is good because we don't have any other colors. Now the length function, len, can be used on lists to tell you how long they are, how many elements they contain. So in this case, we've got colors and shapes. Our original function, this is from the last slide, print the colors one at a time. This is the condition, I less than 3. We can generalize this function to take a list as an argument. So this colors is bumped out of the function. Instead, we have a list as a parameter. Still have that initialized looping variable. Instead of a 3, we have the length of the list value. Print list value I, and then increment I. So now the function will work for our 3 element colors. It'll also work to print out all of these shapes. Now if we didn't change this, then what we'd get if we input shapes is just the first 3. Note that the length here for these is going to be 3, and colors is going to have a length 3, shapes is going to have a length 4, and that fits nicely with the less than sign. So the indexing begins at 0, so this is the 0th indexed element, this is the 1th, this is the 2th, but if you look at how many there are 3. For loops, lists are very useful, any kind of sequence data type, because the for loop recognizes how long the object is and iterates that exact number. So you don't need to calculate it with the length function here. So here, if we simply want to print out the elements of a list, we can do that with a for loop. Define print list, takes that list as the argument for list item in list value. So whatever list is passed to the function, we're going to examine each element of that and print it out with a tab in between. So this doesn't need you to initialize a looping variable, doesn't need you to increment anything, doesn't need you to calculate the length. It's just the for loop structure. It recognizes how long it is. So it's a little simpler than what we see up here. Okay, mathematical operators for lists. These include a plus sign and an asterisk for multiplication. And as we'll see, this is very similar to how these operators can be used for strings. So if we have one list A, it's the number of integers 1, 2, 3, B 4, 5, 6, C is A plus B, C will be a list 1 through 6, kind of the list of the range 1, 7. It concatenates lists. It takes the second one and puts it to the right of the first one. The times operator repeats a list a given number of times to create a new list. So here a 1 element list with a 0 can be multiplied times 4 to create a 4 element list, all of the elements of which are 0. You can repeat something like a sequence. Here the list 1, 2, 3 times the integer 3. So the plus operator takes as its operands 2 lists here. The multiplication operator takes a list and an integer. And that's kind of the same as we saw with strings. There's an operator called in. In checks membership of a given value in here a list and returns either true or false, these Boolean values. So here are our features list, point, line, polygon. The statement point in features evaluates to true because this string is in the list. It's one of the elements. Now, if you typed something else, if you did a typo, then that would become false. Or if the typo, a little bit more pernicious, if it's just a capital P, you'd also get false. It's case sensitive. So be careful with that. But it's a good way to check. List slicing, as we saw earlier, you can reference more than one element in the list by inserting a colon in here. So here 1:3 begins at the number 1 location, goes up to but not including 3. So that's going to give us 1 and 2 index location. Remember the leftmost is 0. You don't need 2 integers with the colon. If you put the colon to the left of the 4, it's going to by default a 0 here. You don't need to type that, though. It's going to give you everything up to, but not including 4. So 0, 1, 2, 3, 4. It's going to give us A through D. If you have list 3 colon, it's going to start at the 3 and give you everything to the end, the right of the list. And then if you want to just put a colon in there with no index, the output is going to be everything in the list. But this isn't pointless, and we'll see in a second. So when you copy a list, you can do so like this. X is the integers 1, 2, 3 in a list. Y equals X. You can, because lists are mutable, you can change the leftmost, the 0 index value of Y to be a 2. If you print it out, you're going to get 2, 2, 3. Try that here. There you go. What about X? X has changed too. Even though we only assigned 2 to the 0 index of Y. Now what's happening here, why both of those variables are getting changed, is because of what Python is doing with these objects. One way to tell is to use this ID function, which will spit out a number. It's going to be different in every session, every time. It's the memory location of the object referenced by the variable. ID X, ID Y. It's the same number. It's different from what's in the slide, but here it's the same in the session. Now what's happening here can kind of be illustrated by these two figures at the bottom. So if you have the string banana, you can create two variables, A and B, each referring to that string banana. And you can have banana, that string, saved to two different spots in memory to have two different values for ID. And that's what this kind of left diagram is showing. But in the sake of efficiency, A and B, these two variable names, can refer to the same single string, B-A-N-A-N-A. So it has the same output for ID, same object in memory. One of the reasons this happens with lists is because they're relatively big in memory compared to tuples, compared to a range object. They're, I don't know, it depends on the length and what you've got in them, but they're definitely going to be bigger, 50%, twice as big, 3 times as big. I don't know exactly, but there you go. So to save space, you can use two different variables to refer to the same object. That's what is happening by default with lists. That's what happened right here. Now, that could be fine, but you want to know if it's happening. This is called aliasing. It's changing the labels attached to the box, but putting another label on, really, adding a label. But it doesn't make Python make a unique copy. Now, we can do that if we want to, but we need to be deliberate. It's not the default. In order to create two different objects, even if one's based on the other and they're identical, you can do that using slicing, using only the colon. So in this example, we've got C equals 1, 2, 3. D doesn't equal just C, but we're slicing all of C, making a deep copy. So C 0 equals 5, so that's what we'd expect for C. But for D, it is not modified. So let's see this. C equals 1, 2, 3. D equals C. There you go. D 0 equals 10. D, C. So there we go. This is very much like the XY example up here, But here where I slice, C and D are unique objects, not just unique variable names. And so here, when I run the ID function, names are similar if you only look at the first 5, but you can see that the 6th digit up here is a 3, it's down here it's a 0. They're different. End in 80, end in 40. So they're unique objects in memory. And if you modify one subsequent to the copying, it's not going to modify the other. And it's just more examples here. So using the list as argument, we can take another look, putting them in functions. Here, we've got a list numbers. We're going to call head function, tail function, passing that list as the argument. We can go up here to see what it's being done. For the function head, it takes a list and returns the 0th element, so the leftmost, the first. If we call tail, it returns what element? So a list, variable name, in brackets, the length of the list minus 1. So remember, length would start at 1, it wouldn't start at 0. So you need to take that 1 off at the end. And then finally, delete item, which takes 2 parameters, a list and an I index. So if I index is less than 0 or greater than the length of the list, print index is out of bounds, or if it's a valid index location, delete the element of the list at that index location. So if we call that function numbers and then the length of numbers divided by 2, basically the middle index location, what that'll give us as output is 1379. This 5 is gone, deleted. A matrix. So a matrix can be expressed as a two-dimensional list, a two-dimensional space here. Each row, expressed as a list, can be nested as a sublist within the broader list. So here, this matrix here, kind of 1, 2, 3, 4, 5, 6, 7, 8, 9, 3 integers on each of 3 rows, can be expressed here as matrix, a 3-element list, and each of those elements is a 3-element list. And the elements of those are integers. So you can access each row by passing a single index location, but you can also access each individual integer by passing a second. Strings and lists. So I'll cover 2 methods here, the split method and the join method. So split, we call it on a string here. My string, the autumn in New England. My list equals my string dot split with no required argument. So if you print that out, you get a list of each word in the initial string. And the way it recognizes it's a word is because the default value to split up this string is a space. That might make sense for you, but it might also lead to an error. You can pass an argument here, the word in, to replace the space character as the value on which the string is split. If you do that, it won't have a runtime error or anything, but your output will be here. A 2-element list, the first being the autumn space, and the second being space new space England. So by default, it's going to split on every space, but you can also split on the word in, or you could split on the word new or autumn, anything you wanted, you could put it in there. The letter T, I don't know. But just think about what you're going to get and check it. Now join will allow you to construct a string that will put elements together. So here we go. My list is the output of what we've got here, split up. the autumn in New England. This is the output of the default split, so where every word is split on the spaces. You can call join on a string, so that's a string object, and you pass the list as where the elements are being pulled from. So the output is going to be a string where each of these words is joined not by a space but by an underscore. If you wanted to really put it back together, you could call it on a space character. So these two methods are called on strings, but they both involve lists. The function is looking to a list to see what to put back together, so to speak. It's going to be the argument here. So what did we cover? Lists are very useful in that they're sequential. They work very well with the for loop especially, but any kind of looping structure. They're mutable, heterogeneous, so they can hold different types of data objects. We learned about shallow and deep copying, aliases. That's kind of when we were looking at how objects are stored in memory. And if you want to be efficient, if that's fine for you, that's great. You can accept the defaults. But if you want to create a copy of a list, go on to modify one copy while creating the other, or while preserving the other without making changes to it, you're going to need to create a deep copy, splice it. Looked at a couple useful string functions: append, extend. Spring and list involve functions: extend, append, join, split. And saw, at least quickly, how nested lists can be used to represent matrices.